This is Monday. And BCA-101, Introduction to Computers and Information Systems. Before we get started on that, Tech Den this Friday we're doing a wiring project. It started around 9, maybe a little sooner. Alright, so today we are in, this is week 14, so we have 2 weeks left. This is like day 38, I believe. Introduction to Computers and Information Systems. Okay, we're going to talk about bottom-up design, compare it to top-down design. We're going to do that over here in just a minute. Talk a little bit about the introduction to programming, what it means to code. Talk about some design options, pseudocode, flowcharting. Talk about this idea of going from source code to executable code. Today, they finish up their database projects, and we move the due date for the individual database back to Wednesday. So we'll get this done today too. So, the other day we talked about top-down design. You got some problem, you analyze it, make sure you understand it, design a solution, develop the solution, and implement it, and then see if it's working. We talked a little bit about each one of these. Each one of these would have these, I call them feedback loops. The idea is you would come up with some analysis, and then you'd see, is that right? You know, either with your team or your client or whoever you're working with. Okay? And then when you evaluate, if it needs corrections, if you still have a problem, then you go back through these steps again. So it's kind of like a cycle. Now, another way to do this, let's go a different color. You can take your problem and take these steps, and rather than refine them, go through them quickly, and then develop a prototype. So you don't have all the details, but you can develop a prototype and start testing it, and then you do the same thing here with your prototype. You keep refining and refining and refining it. Okay? So that idea is a bottom-up design. Okay? Sometimes in programming they call it sprint or agile programming. Some examples. Let's say, how do you create a presentation? A lot of people do it bottom up. You create some slides, see if you like them, rearrange them, do a little work with them, create some more. So you're really building from the bottom up. You're creating a prototype and then refining it. Spreadsheets are often done that same way. Let me give you a non-technical, well, it could be technical, but if you were going to build a house, you probably would have to do that. That would probably have to be done top down. You'd have to decide, okay, do we need a new house? How big do we need? What kind of things you're going to have in it? And so forth. You analyze, come up, and we have enough money, and so forth. You might even start thinking about design. And then somewhere in there you'll say, well, we could buy instead of create. So you make that decision. If you decide to build, then you would have all the plans done before you start digging a basement. I built a tree house bottom up. First thing I did is I got the lumber before I had any design. And then we had the tree in our backyard. Then I took a board, put it on the tree, made sure it was high enough so I could mow under it. Oops, mow this grass underneath here. and then I just build it from there. Okay. And put some railings on it. I actually built a slide, had some steps, so it was a cool treehouse. But anyway, that was bottom up. Now, a problem with this, if I would have found some structural error in my building, I might have had to do what? That's a funny way to word that. You might have to tear it down and start over. Okay? So there are some issues with bottom up. Plus, some software design or information systems, they are high impact in terms of they are not, you cannot have them fail. Okay? Like air traffic control or managing the systems inside an airplane while it's in the air, large systems that manage the grid, the power grid, and et cetera, et cetera. So we could name lots of those. All right, so that's it for that. Now let's move ahead here. I talked a little bit about databases here. If you're doing a calculation, make sure you're rounding them. And here we talked about birth date. You would store somebody's birth date, not how old they are, because you can calculate how old they are from the birth date. And if you're doing calculations in the database, make sure you round it. And then I talked a little bit about the relations. If you have a table of information, and you have some relationship between them, you have to do that appropriately and make sure you link it. Now, how does the development of software relate to this? Well, let's take a look. Similar to our top-down design over here, you need to understand what you're trying to solve and then look at the specifications. Okay, you need to know what you're going to be able to put in, and you need to know what you want out, and then what kind of processing you're going to do in between. When designing, we can do pseudocode, which is false code. That would be like text, or flow charting, where you would draw boxes and show the flow of your program, and maybe you have a loop, maybe you'll make a decision and do this or this. Okay? You have a flow chart that has the flow, or pseudocode, which will have text of the information. Once you get the design, or the start of the design, then you can develop it. Implement, evaluate. And again, same old thing. If it isn't working quite right, you make new specifications and run down through the steps again. Now, in a lot of cases, you'll be able to prototype software. You can get an idea of where you want to end up. Okay, where you want to end up, but you can create a prototype and then test that, and then add to it. And then test that, and then add to that, and test that, and work your way towards your goal. So that is possible to do that also with software. Now, in the development, people write source code. You can develop source code from pseudocode or flowcharts. You write it in some high-level language. And then we rattled off some high-level languages. What would be some examples? Somebody said C#, C++, Java, JavaScript, Python. Then I rattled off Pascal, Fortran, Cobalt, assembler language. There's all kinds of languages. These high-level languages, assembler is a low-level language, in which people write source code, and then that source code gets compiled or interpreted based on an OS, and we develop object code. This is something the machine can understand, the computer can understand. Then we bring in other libraries of code and we create an executable that the machine runs, the computer. That computer could be your phone, your iPad, PC, laptop, all those different things. When we compile or interpret, it's based on the OS. That's why a piece of software that runs on a Mac doesn't directly run on a PC, because the Mac has a different operating system. Not so much the hardware is different, it's that the operating system is different. Source code, what humans write, executable, what the computer functions or works with. So when we talk about open source, that's saying that the source code can be changed or adjusted by somebody. It's not proprietary. Talk a little more about that on Wednesday. So, software can be designed and developed both bottom up by creating a prototype and building on it, or top down by going through the steps and making sure you got the design correct before you actually develop the code. Okay? Oh, by the way, we gave an example here. Executable code, PuTTY. And if you remember, PuTTY worked on our PCs but didn't work on the Mac. That's because it would have to be compiled for that operating system. We talked a little bit about directions, so the students need to be working on the last project, project number 5 on databases, individual project. We have then the skills-based test on Friday for databases. Next week we do coding and some data analysis on Monday. Wednesday we finish the unit, then anytime after Wednesday people can take the final. That's it.